Have you ever looked up at the night sky and wondered what lies beyond that shimmering river of light, the Milky Way? For thousands of years, humans have stared at it, told stories, and dreamed of exploring its mysteries. Today we know the Milky Way is our home galaxy, a colossal, spinning city of stars, gas, and dust. Our sun is just one of hundreds of billions of stars in this vast structure. Imagine standing in the middle of a glowing city, looking toward its bright center. That's what we see when we gaze at the Milky Way. We now use telescopes to peer deeper, seeing swirling nebulae, ancient star clusters, and even the faint smudges of other galaxies. The questions have changed, but the wonder remains. Can we ever leave our stellar neighborhood and explore the great unknown? This is the ultimate adventure, one that began with the first person who dared to ask, "What's out there?" Now we stand ready to ask the next big question. Can we ever leave our own galaxy behind and journey into the cosmic sea? The journey from wondering about the stars to actually traveling among them is humanity's greatest quest. The night sky still calls us to explore. To leave the Milky Way, we first need to grasp its staggering size. Our galaxy is a barred spiral stretching about 100,000 light-years across. A light-year is nearly 6 trillion miles, an almost unimaginable distance. If the Milky Way were the size of North America, our solar system would be smaller than a quarter. All of human history has unfolded on a microscopic speck within that tiny quarter. Even our fastest spacecraft, like the Parker Solar Probe, would take thousands of years just to reach the nearest star, Proxima Centauri, still inside our galaxy. Crossing the Milky Way would mean traversing a void 100,000 light-years wide. Our technology is like trying to cross an ocean in a rowboat. The galaxy is both our home and a beautiful prison of distance. The scale forces us to rethink everything about travel, time, and technology. The challenge is immense, but so is our curiosity. Let's talk about Voyager 1, humanity's farthest explorer. Launched in 1977, it sent back stunning images of Jupiter and Saturn, then kept going, carrying a golden record for any distant life it might encounter. In 2012, after 35 years, Voyager 1 crossed into interstellar space, leaving the sun's influence behind. It's now the most distant human-made object, a lonely pioneer in the cosmic ocean. But even at 38,000 miles per hour, it's only covered a tiny fraction of the distance to the nearest star. At this speed, reaching Proxima Centauri would take 75,000 years. Voyager 1's journey is inspiring, but it also reveals our limitations. To leave the Milky Way at Voyager's speed would take hundreds of millions, even billions of years. Our first step into interstellar space is just that, a single step on an endless road. True intergalactic travel will require a revolution in how we think about distance and time. The cosmos demands new ideas. If we could leave our galaxy, where would we go? The closest major galaxy is Andromeda. It's a massive spiral, visible as a faint patch of light on a clear night, our nearest galactic neighbor. But Andromeda is 2.5 million light-years away. That means the light we see left Andromeda when early humans first walked the Earth. Imagine driving a car at 100 miles per hour. Reaching Andromeda would take 17 trillion years. Even our fastest spacecraft would need billions of years to get there. The distances between galaxies are on a scale beyond comprehension. This isn't just a technological challenge, it's a problem of time itself. The human lifespan is a blink compared to the journey required. Intergalactic travel is a dream that dwarfs even our boldest ambitions, but dreams are where exploration begins. Why not just build a much faster ship? Here's the catch. The universe has a speed limit, the speed of light. Einstein's theory of relativity tells us nothing with mass can reach or exceed this speed. As you go faster, your mass increases, and you need more energy, an infinite amount to reach light speed. Even at 99.9% the speed of light, a trip to Andromeda would still take over 2.5 million years from Earth's perspective. Time would pass differently for travelers, but the journey remains immense. The speed of light is fast for us, but painfully slow for crossing galaxies. The laws of physics set a hard boundary on our dreams of intergalactic travel. We can't just build a faster engine and hope to get there. But when faced with a wall, humans look for doors, or even secret tunnels. The universe's rules challenge us to think beyond the possible. And that's where imagination takes flight. If we can't break the speed of light, how could we ever reach another galaxy? Here, science meets imagination. One idea: Generation ships, vast self-sustaining vessels where generations live and die before reaching their destination. Another cryosleep, putting travelers in suspended animation for the journey. Or what if we could bend space itself? Theoretical concepts like wormholes, shortcuts through space-time, or warp drives that ride waves of space-time could one day make the impossible possible. These ideas are pure speculation for now, but they show our relentless curiosity. The journey may seem impossible, but history is full of impossible dreams made real. Our descendants may one day find a way to distant galaxies. Until then, we keep asking, keep dreaming, and keep reaching for the stars. The night sky is a cosmic invitation. Our story as explorers is just beginning. Who knows what shores we'll reach? The universe is waiting.